Today, as it says right up here, we're going to talk about fractions. Fluency and fluidity, whatever the heck that means. But so here's what we're going to do. Here's what I'd like to do. I want to spend a little time defining some terms, share some evidence of how our kids are kind of up and down and over and sideways with fractions. Quick review of the research on why, and then spend a little time looking at how technology can help try and remedy some of the issues that our kids seem to have. So a lot of this is going to be research drawn from the development of a program called Fractionation, which is coming out the end of the year or January, I think. So we poured through a lot of research and had a lot of did some of our own research on this, and it's kind of interesting what we found. So what do I mean when I say fluency and fluidity? So fluency is accurate with little effort. There's a wonderful book about why some kids struggle with math, and Steve has a chapter in it. He's got a bunch of papers as well. But what's the biggest predictor of kids struggling with fractions? Concepts. They don't understand what fractions are, and they're not paying attention. I'm going to talk about both of those. As they go further, it's like the kids don't have math facts, then they really are beat down when it comes to equivalence. It's really hard to see thirds and twelfths and make them the same denominator if you don't know your math facts. But even baser than that, dealing with just unit fractions. Kids don't have fraction concepts, they can't do it. It's not about procedure, it's about understanding what it's about. A lot of instruction in the US, there are problems with it. One problem is we load kids up with all the definitions of a fraction. It's a measure, right? It's like, we have a measuring stick. You guys know this. It's on a ruler. It's a measure. It's a ratio. It's a comparison of two different things. Well, actually, it's a division. But it's also part of a whole, so you've got, and it's part of a whole with sets, and it's part of a whole with continuous quantity. And of course, when you use fractions as a multiplier, it's the same thing as a percent. And it's like, whoa. That's a lot. And for kids who are struggling to begin with, so what is it? What am I supposed to do with it? And we have a problem with doing too much at once. We often treat fractions as a separate number system. We do whole numbers on a number line. Great, got it. And it's like, now we're doing fractions. Now we're in pizzas. And kids do not see the connection. There's great research out there that fractions are its own number system, whole numbers are a different system, and when we do decimals as point something, we really screw them up, like 0.12. What's that? That's not this system, that's not that system, that's a whole other system. So we are not creating this as a whole for kids, so to speak. How can technology help? So technology can help in several ways. One, it can help assess to find out where a kid's breaking down. How far back do I need to go with these guys? Technology is great for representing visual models to help connect their informal experience to something formal, to generalize that the fight they had with a sibling about, no, you're getting more than I am, to something there's a deeper understanding generally about what half of something means, or less or more than a half. We can help manage cognitive load. The research is very clear. We have a limited capacity in what's called working memory. Working memory is the part of the brain that works on tasks, but it gets overloaded very quickly. And so we need to help kids distribute processing power to other parts of the brain. That's one thing that fluency gives you. Fluency often means that I've taken something that used to be laborious, and you can think of any kind of task in your life. Think about if you have a little kid or when you were a little kid, walking, how much focus there was on walking or walking up and down stairs or tying your shoes, but you do it over and over again and all of a sudden I didn't even think about it. There are a lot of things in our lives, our daily routines. Did I lock the car? Did I put on deodorant this morning? Did I put on deodorant this morning? The things that we do, they're almost automatic. And so by doing those things, by rehearsing them, by becoming fluent with them, we move it out of working memory and put it in a different part of the brain. So the fractionation, what we did to try and address this is we developed a placement assessment with items like that to say, all right, where are kids? If they're struggling with that, making a match between a numeral and a picture representation, they don't have a really good sense of what that fraction means, we've got to start back here. If they have a good sense of that, what that fraction means, but they're still struggling with the unlike denominators, then maybe we can pick them up right here. But we're not going to do addition and subtraction until this is solid. You can't really add and subtract without understanding fractional equivalence. What we did in this fractionation program is we took and broke this path down into 64 bite-sized steps. Each about 15 minutes, about a 15-minute independent lesson for each one of these. And so it's like, you know what? I'm going to be able to get this. Not too much. And each one builds on the last. Remember what we just did? We're just taking a little step forward from that. I have constant progress and being able to see my progress through this. And then supports. What kind of supports can we add? Well, I don't remember what denominator was. And I don't speak English that well anyway. So we can provide vocabulary support as needed for kids. We can provide hints. Count the number of equal pieces in one whole. Little helps along the way. Multiple representations. Here's a number line. That's a little more abstract. Let's do something concrete. Jumping kids to a number line can be tough because it's a higher level of abstraction. So the research suggests staying with that linear representation, but one that's more concrete, moving to one that's more abstract, so we can have those supports and adjust them along the way. And then we can adjust the demands, the task. And that can be very simple. So here's a task of what's missing here. And you've got it segmented out. And the answer goes over here. And we can adjust that, make it even just a little bit harder. And so we're getting at that kind of fluidity. If you always the same task of the answer's always over here, and I can count the number of things, then you're not giving the kids the flexibility. And it can be very simple, like, oh, wait a minute, the question's over here. I haven't seen it over there. And I don't have anything to count here. So we can make the task incrementally, subtly stronger. I'm not talking about making the numbers harder. That's really not what it's about. It's often saying, taking that same, unless it's about making the numbers harder, what you really want to do is say, do you really get this? Can I do it in ways that are a little bit different? Can I recognize it in formats that are slightly novel? There's a researcher we've worked with who uses this wonderful phrase of dimensions of novelty. And it's kind of a fun thing to think about. It isn't just about doing the same thing over and over again. We want to move them forward. And we can do it in subtle but very important ways by varying the dimensions of novelty over time. Focused practice. You can't get fluent without practice. We want to stop the negative cycle, see, I told you I couldn't do this, to one that is, yeah, with work I can do that, and it feels pretty good. This is what we want.